Hey guys, welcome back to Integrating Every Day until we reach 1,000 days. Today we are gonna do the monster integral that I told you I'd do tomorrow, but I think we should just do it today because it's a pretty long one. And day 40, I'm not sure. Special day. So, the infamous square root of tan x is finally be triumphed by the cube root of tan x. But still, we can recall what Prashant sir told us and take u as the cube root of tan x. And then we cube both sides this time. So we get u cube is tan x. So now note that sec squared x is equal to tan squared x plus 1, which is just u raised to 6 plus 1. So we get 3u squared du is equal to sec squared x dx. So we get dx finally as 3u square divided by u square whole cube plus 1 du. You're going to see why I wrote it like this. So we get the integral of u times 3u square divided by u square whole cube plus 1 du. Now you're going to see a bunch of u squares and you're going to want to get rid of them. And that's going to be pretty useful since there's just an idle u over here. All we have to do is divide by 2 and multiply by 2. And then we can let t equal to u square. dt just becomes 2u du, which we already have here. So then we have the integral of 3 by 2 times the integral of t divided by t cube plus 1 dt. Now this, I want to say it's a simple partial fractions question, but you're going to be in for a ride with this one. I'm just going to tell that. You have to write it as t divided by t plus 1 times t square minus t plus 1 and let it equal to a by t plus 1 plus b t plus c divided by t square minus t plus 1. So now what you're going to do is we have this equation a times t square minus t plus 1 plus bt plus c times t plus 1. So if we want to get our first constant, what we're going to do is we're going to make this term vanish by plugging in negative 1. So if we plug in negative 1, this becomes minus 1 plus 1, which is just 0. So this whole term goes to 0 like I said. So we'll have negative 1 is equal to a times negative 1 whole square, which is just 1, minus of minus 1 plus 1. Therefore, 3 times a is equal to negative 1. A is equal to negative 1 over 3. Pretty good. So now we have t equal to negative 1 over 3 times t square minus t plus 1 plus bt plus c times t plus 1. To get our other constant, we want another constant of ours which we don't know to go. So we know that b and t are in multiplication. So what we're going to do is set t equal to 0. What that will give us is 0 is equal to negative 1 over 3 times 0 square minus 0 plus 1 plus c times 0 plus 1, which is just c, which implies that negative 1 over 3 plus c is equal to 0. Negative 1 over 3 plus c is equal to 0. Therefore, we get our other constant, which is c equal to positive 1 over 3. Now all we have to do is just plug this back into this equation. T is equal to negative 1 over 3 times t square minus t plus 1 plus pt plus 1 over 3 times t plus 1. Now to get b, all we have to do is just let t equal to 1. So 1 is equal to negative 1 over 3 times 1 square minus 1 plus 1 plus b plus 1 over 3 times 1 plus 1. So 1 is equal to, this just becomes negative 1 over 3 again plus 2b plus 2 over 3. So now if you take everything to the other side, you will get that 2b is equal to 1 minus 1 over 3 and hence b is equal to 1 over 3. I just skipped a lot of algebraic steps because Our main objective is to simplify this integral. So this integral becomes t by t cubed plus 1 dt becomes, now since all the constants are 1 over 3 in this expression, I'm just going to take the 1 over 3 common. This 3 times 1 over 3 will just become 1. So we'll have 1 by 2 times the integral of negative 1, wait, I'll put a big bracket there, negative 1 over t plus 1 dt plus the integral of t plus 1 divided by t square minus t plus 1 dt. So this is just a simple formula. This is going to be 1/2 times the integral, the natural log of t plus 1 with a negative sign plus 1/2 times, now we're going to call this I, and we're going to solve this on the next page. So on this page, let me see if it's in cam. Yeah, it is. We have the integral of, what is it? Okay. We have the integral of, it was w plus 1 divided by, no, what did I say w? T plus 1 divided by t square minus t plus 1. Yep. We have this. So what we're going to do to this is actually multiply and divide by 2 and then write this as 2w minus 1, because if you differentiate this you'd get, 2t minus 1, because if you differentiate this you get 2t minus 1 plus 0. So we want to get it in the form of f dash of x by f of x dx, or f dash of t divided by f of t dt in this case. So we can get the integral as ln of f of t. So what we're going to do is, like I said, 1 by 2 times 2t minus 1 plus 3 divided by 2, because we took the 2 outside, divided by t square minus t plus 1 dt. Now this is just going to be, this is just going to be 3, sorry, I'm bad at algebra. So this is just going to be 1/2 times the integral of 2t minus 1 divided by t square minus t plus 1 dt plus 3 by 2 times the integral of 1 over t minus 1 by 2 whole square plus 3 by 4 dt. Now why you will see that I wrote this like this is because if you notice t square minus t plus 1, it's just t square minus 2 times 1/2 times t plus 1 by 2 whole square, no, plus negative 1 by 2 whole square plus 1 minus 1 by 4. Since we added a 1/2 whole square here, we have to subtract it over here, and this is just a minus b whole square, so it's t minus 1 by 2 whole square, and 1 minus 1 by 4 is just 3 by 4. Now we wrote it as a difference of 2 squares. This is not really a perfect square, but we're going to let it, just so that we can write it as the arctan formula. It's not a difference, it's a sum. So 1/2 times, this is just f dash of t divided by f of t dt. We know that is just ln of f of t, which is t square minus t plus 1 plus 3 by 2 times 2 divided by root 3, 1 over a, times the tan inverse of t minus 1 by 2 divided by root 3 by 2. So now we had a 1/2 of I, that would be equal to 1 by 4 times the natural log of t square minus t plus 1 plus root 3 by 2 times the tangent inverse of 2t minus 1 by root 3. So in the end, we just have to add all of our integrals, which is this plus 1/2 I, which we got, and we have to back substitute everything. So we have negative 1/2 times ln of, I think it was t plus 1, plus what we have here, 1/4 times ln of t square minus t plus 1 plus root 3/2 times tan inverse of 2t minus 1 by root 3. Now, before we write plus or minus c, we're going to say, we know that u square equal to, it was tan square x taken in the cube root. And now we know t is equal to u square. So all we have to do is just substitute tan x whole raised to 2/3 everywhere we see 3. Everywhere we see t. So the integral of the cube root of tan x dx is equal to negative 1/2 times the natural log of tan x whole raised to 2/3 plus 1 plus 1/4 times natural log of tan x whole raised to, now this is t square, so instead of 2/3 it becomes 4/3 minus tan x whole raised to 2/3 plus 1 plus root 3 divided by 2 tan inverse of 2 tan x whole raised to 2/3 minus 1 divided by root 3 plus or minus c. This integral was really hard and really lengthy. So I hope I didn't bore you with this. This was a monstrous integral. See you guys next time.